everybody. This is a college algebra final exam review workshop, and we're going to be working in the college algebra study guide. It's from my math lab. I'm going to be working with, and I've printed it out, so I have it in OneNote. We're going to be working in that. I've circled a few problems. We won't be able to do the whole entire study guide. I've circled a few problems that we're going to just highlight, and so that doesn't mean you study only those problems. It just means that we picked out those problems to present to you as a good rounded review session. And I'll let Mr. Simon introduce himself, and he always opens up with a dad joke or a few. So let's see what he has today.
Hey guys, Professor Simon here. I'm sure you've seen me before. I tend to be all over the place these days. Hopefully Miss Flanders has been pushing my YouTube channel, so you would have seen me there or in one of these other workshops. So we'll get started officially here. We'll get the old dad joke going. I got my son playing soccer the other day, and he said, I don't know if I really like soccer as a sport. And I told him, well, you should really just do it for the kicks.
That's a good one.
It's a good one.
That's a good one because I play soccer.
Do you do it just for the kicks?
I do it for both, the kicks and the pleasure.
There you go. All right, Vicky, here's a joke for all you Catholics out there. How do you make holy water?
How do you make holy water?
You boil the hell out of it.
Oh my goodness. All righty. That's funny stuff, Dave. Okay.
Well, it's a joker at best, but hey, it's fun.
It is funny. Okay, so here is that study guide I was telling you guys about. You can see it, it's like my math lab. It's going to have the answers here. So the ones that we don't work, you can try to work them and, see if your answers are correct. The answers I said, are posted right underneath each problem. Okay. And this is I think the study guide, I forget how many, let's see how long, the study guide's pretty lengthy. If there's 35 questions. Your teacher may or may not have put this in your My Math Lab homework. I mean, it might be in there, it may not. Depends on your teacher's discretion. So what I did is I just printed it out here and have it in OneNote. And we're going to kind of hop around.
Vicky, is this the one that Troy made, or is this a different one?
This is the one from last semester.
Oh, okay. Because there's one of these that Troy gave me like 3 or 4 years ago that is formatted similarly, but I think it has 50 questions on it.
Okay. Well, this is a little bit later than that. So this is last semester. You can see the date up here. I got it from my thing last semester.
Oh,
it says
20? Yeah.
Where does it say it at? Somewhere. Well, now I don't see the date.
Oh, no, that's the page number. Sorry.
Oh, spring.
11/13/2020.
Oh, there it is. So yeah. Okay. Alrighty. So I think I had the first number I highlighted was it number, what was it? Right here. I think it's this one, number 9. Okay. And it's now this study guide is out of order from how the material was presented. Okay, so we're just going to go in order of this study guide. So this is all mixed up. And this is a logarithmic equation to solve. And this was towards the end. This is in chapter 4, towards the end of the course, of the college algebra course. So Dave, what I thought about is
I was going to say, why don't we just work them on the side of each one so that you don't have to cut and paste.
Exactly.
We'll just have to combine.
Exactly. There's a lot of room here. I think we'll just work on the side. You're thinking exactly like I was doing. Okay. So it's a logarithmic equation. You want me to go first? Is that how we normally do it? Okay. So work it out here. I'll just copy it over. I'll just copy it over. Log base 2 of x plus 8 is equal to 4. And what we do is we're going to use the equivalence. We can rewrite this in an equivalent equation using the properties of logarithms, or there's a formula, so to speak, that changes this from exponential form, or from logarithmic form to exponential form. Okay, so if you heard me say, if you read it correctly, that'll help you. Log base 2 of x plus 8 is equal to 4. Okay, so if I change it to an exponential equation, the base is 2. The logarithm is the exponent, so 2 to the 4th power is equal to the argument of the logarithm, which is the x plus 8. And now this is a exponential equation, and actually it's not. Now I put it in exponential form, but it's really now a linear equation. So 2 to the 4th power is 16. 16 is x plus 8. So 16 minus 8 is 8. So 8 is equal to x. Now, when I solve a logarithmic equation, I need to make sure that I should check my solutions, especially if you have more than one. I just have one solution, so I am going to check it anyway. And all I really need to do to check it is make sure it's in the logarithm's domain. And as soon as I put it in, 8 plus 8 is 16. That's positive number, so I'm good. You cannot take the logarithm of a 0 or a negative number. Okay, so when I put 8 in, I get 8 plus 8, 16. That's positive. I'm good. But you could go further and completely check it. You know,
you can take the log of a negative number.
What's that?
You can take the logarithm of a negative number. It's imaginary.
And okay, say that. Yeah, exactly. So it's imaginary, which we're not doing that. We're staying in the domain restriction of the argument being greater than 0. All right. So log. I'm just going to kind of check here, and if I do, I'll get log base 2 of 8 plus 8 is equal to 4. And you can see here, and if you can realize there's several ways you can check this, but you can see right here the 4 matches the 4 right there. If you the bases are the same, the exponent is the solution, or the exponent is the answer of the logarithm, because it's asking you what's the exponent on base 2. Okay, and that is 16, and it's 4, and that's what this logarithm is equal to, 4. So that checks out. So there's different ways you can check that, but that's one way. Okay, alrighty. Any questions? It seems like forever ago that pre-calculus has seen the college algebra stuff. That was way back a few months ago.
And it goes so fast.
It does. It flies. All right, anybody? Daryl?
I do have one question.
Sure.
I do understand logarithms, but when you say to take the logarithm of a number, does that mean like log? Can you write that out for me?
Take the logarithm of a number?
Of any number, like x?
Yeah. So I can say I have to have a base. So I have to have a base. Give me a base. Logarithm base what?
Well, it can be just that, 10. Or
10. Okay, it could be 10.
Yeah.
I'll just put the 10 here anyway. Of what? Give me a number.
X? Or 17?
Okay, let's say 17. And you want to know what is this equal to, right?
Yeah.
Well, because 17 cannot be written as base 10 as an integer. So how about if we put a number? Well, let's just do one with the integer first, like 1,000. Well, I can write 1,000 as base 10. 1,000 is 10 cubed, so the answer is 3. So when I have something like log base 10 of 17, what is that? What does it mean? It means 10 to the, let's put an X right here. 10 to what? 10 to
1.23
is 17. Okay. So that's what it means. Okay. So what is that? What is that number?
1.23.
Okay. So, it's a little bit bigger than 1. I knew, see, 10 to the 1 is 10.
Yeah.
10 squared is 100. So I know that 17 is closer to 10. So it's going to be 1 point, a little, way closer to 1. But there's different ways you can work. You can say log base 10 of 17. You can actually say, well, that is log Well, you can punch in your calculator because it's base 10. So punch in your calculator.
1.23.
What do you get? Sorry.
1.23.
All right, there you go.
Thank you. Because I understand it, but whenever you say to take the logarithm of a number, there's a lot of numbers there. So I'm like,
Okay, so the is what's in parentheses. Think about f. So think about when you say f of x.
Yeah, just like
okay?
that. Okay.
Just like that, because logarithm is a function. So when I say log of x, then it means log base 10 of x. Yeah.
The base comes with the operation. You can't just say log technically, although we were saying it here with base 10.
Base 10.
If you're talking about it as a function, the base has to be part of the operation, kind of like a cube root. If you left off the 3, it wouldn't be cube root anymore, right? So radicals and logarithms have to have that extra qualifier to say which root, which logarithm. And then the of part is, like she said, the thing that you're acting the log, the thing that the log is eating as an input.
Yeah, that's a good analogy with the cube root. Exactly. And not when you just say root 2, you mean square root. You mean the 2. So if you just say log, you mean 10. But you really should clarify, square root, cube root, whatever, and then log base 2, log base 10, log base e, whatever. And log base e, we say natural log, So yeah, it goes with it. Yeah.
Thank you.
Yeah. Does that help out?
A lot.
Okay, great, great. Okay.
We almost helped too much.
All right, here's the next one, Dave. It's a parabola here. And you guys can see the answers are right there, but let's go through the motions here, asking in it all of these things here. And I would say find actually on this one, I would also say find the vertex.
They don't ask you to?
No.
Oh, wow, I was going to do that anyway.
Let's do that. The vertex, axis, symmetry, domain, and range. Yeah, we could also ask for the x-intercepts and the y-intercept. So that's probably something that I would ask on a test as well. So I'd ask for a few more things. Okay, so Dave, you take it over. Do you want me to
no, what you had was fine. What you had was fine.
Okay.
So whenever we're given a quadratic function like this and we want to graph it, the best way to go about it is to have as many points as possible. And the easiest points to find are the important ones, which is the vertex and both of the intercepts. Okay. Now, as far as the domain is concerned, that's always all real numbers. That's always going to be the answer for a parabola for a quadratic function. So that's an easy, quick one to get out of the way. After I find the vertex, we can talk about the range and the axis of symmetry. So for my vertex, I'll be calculating the negative b over 2a, which we call h. In this case, that's going to be negative 4 over 2 times 1, which I'm going to get a 2 for. And then the k value is going to be the function evaluated at that negative b over 2a, the h value. So I plug in 2 to the function. 2 squared minus 4 times 2 plus 3. So I've got 4 minus 8 plus 3. So what? 7 minus 8 is negative 1. Okay, so my vertex is 2, negative 1. So I would start by graphing that one. 2, negative 1 is right here. All right. Next, we're going to want to find the intercepts. The y-intercept is the easiest one, especially in this format. That's just where x is equal to 0. So I'll be doing the function evaluated at 0. So 0 squared minus 4 times 0 plus 3, which is just going to give me 3. So my y-intercept is the point 0, 3, which is right here. Okay. Next, my x-intercept is whenever y is 0. That's true for any function, by the way, guys. Don't forget, intercepts are always where the other coordinate is 0. So I have to solve the equation 0 equals x squared minus 4x plus 3. If it were, a more complicated quadratic, go ahead and throw down the formula. But this one's pretty obvious. What can I factor this one into? Anyone?
X minus 3 and x minus 1.
Sounds good to me. So I'm getting two solutions here. I'm getting that x is 3 and x is 1. So we have the point 3, 0 and 1, 0. All right, so we'll graph those. 3, 0 and 1, 0. And it should make sense when you look at it that the x-intercepts are symmetric around the vertex. Everything should be symmetric around the vertex. The line of symmetry is the line that goes through the vertex. That's the line of symmetry right there. So the axis of symmetry is x equals 2 here. And then the range, well, let's go ahead and draw the graph first. You can see the points there, right? It's going to go kind of like this. In fact, you can even look at the answer just beneath, right? Whoops, messed up a little. Close enough. So the range obviously doesn't go any lower than here. So my range is going to be from -1 to infinity with a bracket on the -1. All right. Any questions on that one? Welcome, Alex, for an algebra review.
Hi.
Vicky, are you able to
Alrighty.
grab all of that?
Yeah, let me see what I can do with this. Yep.
Just grab it and then overlay it.
Yeah, that's what I'm gonna have to do. Exactly. That's exactly what I was thinking. I think it's gonna work out just fine.
Sweet.
Okay.
Whoa.
I know it's pretty big, huh?
Yeah, so maybe zoom yourself out and then you can size it. Yeah. Now grab the corner and size it. So no, not that corner.
Let me see how it. Okay.
You've almost
That's,
got it.
that's number 11 though. I mean, it's number 2
Yeah.
here.
It bounced you.
I know. So is that right?
A little bit smaller.
Smaller, you think, like inside this thing?
Because it's got to fit on top of that other graph, right? One of the graphs is cut in half. No.
Yeah.
Smaller. See, it's got to fit where that border is too.
Yeah, I know. I guess something like that.
That's good enough. This is government work. It's good enough.
So, yeah, but look, see, I can go outside of it.
Yeah, you can go a little bit bigger. Yeah, that's fine.
So it'll kind of match the other one. Yeah, a little bit outside.
Because the answer's on there anyway. It doesn't matter that the other one got cut off.
Exactly. That. Yeah.
That'll work.
So something like that.
Cool.
All right. Are you good?
Yes.
All right.
Be right back.
All righty. No problem. All right. Let's see what this one is. This is the next one I think that we have here. They've given us two. Okay, we gotta be careful. So let's just do number 17. They've given us two functions, a f and a g, and they're asking us for several things here. Hold on. Let me see something. I don't think we have to work that one. I think I have another one. That's why I kind of wish they were in order. But yeah. So we're going to work this 29, and I cover F composed of G. So let's erase that one. So if I go back up. So you guys can see there's some repetition. There's some repetition here that we're not going to, we're not going to worry about. You guys have plenty. If you want to work this one and another time, that's okay. All right, let's work this. Let's do this number 18. It says, write the point slope form of the line satisfying the given equations and use the point slope form of the equation to write the slope intercept form. Okay. And we're given 2 points. So let's just say, given 2 points, what I'm going to ask you the slope, because you need that for the point. Then I'm going to do the point slope form, and then I'm going to put that form in y-intercept form, and then I'm going to graph the line. So I do a few extra things here than what's called for. Okay, but you guys should know that we should find the slope first anyway. So to find the slope, I'm going to designate these points x1, y1, and x2, y2. So my slope here, designated by little m, is the difference of the y values over difference of the x values. So x2 minus x1, y2 minus y1 divided by x2 minus x1. And that gives me, what do we get here? 14 minus 12 over 7 minus 6. And I get 2 over 1, I get 2. So my slope is 2. So part B, when I put it in point slope form, and then I'm going to rearrange that, but point slope form is this. Y minus y1 is equal to m times x minus x1. So y minus 12 is equal to 2 times parentheses x minus 6. So y minus 12 is 2x minus 12. And if I add 12 to both sides, I'll get 2x. Okay, so y equals 2x. That is the slope-intercept form. Anybody want to tell me what is the slope and what's the y-intercept? You guys can participate. What do you think the slope is?
2.
2, same as we got in the slope formula. And what is the y-intercept?
The origin.
The origin, exactly. Because it's supposed to be plus b, but there's no b, right? Well, b is 0. We don't need to say plus 0. So the y-intercept is 0, 0. Okay, so let's go ahead and graph that. In part C, we're to graph it. So let's go ahead and maybe use purple or something. So the origin is the y-intercept. And then we go up 2 over 1. So rise 2, run 1. And that gets us our other point. And you can keep doing that. You can keep rising 2, run 1. You could actually go down 2, left 1. Okay? And that all puts you on the same line, but here's the line. All right, guys, any questions? So very basics of lines. Given 2 points, find the slope. Put that into the formula with one of the slope and one of the points into the formula. Rearrange it so that you have y equals mx plus b. Plot your b. Use your m to get your other points. And there you go. You just need one, or you just need 2 points to draw a line, right? Okay, any questions? Okay, pretty straightforward there. All right, Dave, you ready?
I'm here.
Okay, let's see what's next. Lots of good stuff on here. Just kind of try to narrow it down so that it would fit in our workshop.
Loving
How about
it.
this circle one?
Is that
It's
the
got
next?
a lot of learning objectives here. Let me kind of let me try to get it in the
Is that the
screen.
next one on the list?
That isn't, I believe so. Did you see me skip any? I'll go back through and see if I skipped anything. But this is it.
All good to go?
Yeah.
All right. So we have a circle there, and we want to find the equation is the end goal. So of course the equation of a circle comes mostly from the center and the radius. So the center point here is the point that I would like to find first, and then from there I can set some other generic xy point as the edge, and as long as I have the radius, right, then I'll be able to create an equation like a distance formula, because the radius is the same in all directions. So let's start with finding the center point here. It's given that the circle line there intersects through two different points, 3, 3 and 13, 9. Okay, so basically I've been given these 2 points here and here. 3, 3 and 13, 9. So the total distance between these two would be a diameter. So I'll label that D. Half of which, of course, is going to be the radius. Oh, you know what? Let me do it a different way. First, let me find the middle point. That'll be even easier. The midpoint of these two is going to be the center. So to do the midpoint, I'm going to add the two x's together and divide by 2. And I'm going to add the two y's together and divide by 2, basically just averaging the x's and averaging the y's. So my center point is going to be 8 and 6. Now that I have the center point, the distance, as we just said a moment ago, between the center and the edge is the radius. So I can actually directly calculate the radius now using the distance formula. The distance between the two is going to be 8 minus, and it doesn't matter which one you pick. I'll pick the outer one, 13 squared plus 6 minus 9 squared. And I just have to simplify this. So I've got square root of 8 minus 13 is -5, squared is 25. And 6 minus 9 is 3, -3 in this case. Squared, though, is 9. 25 plus 9, I've got the square root of 34. Okay, so now that I have the center and the radius, I can easily set up the equation of the circle by x minus the center x, 8, plus y minus the center y, 6 squared, and then the square of the radius. This has to be r squared. So notice that what I'm actually doing is this, but since square and square root are inverses, in this case, they are able to just wipe each other out. So therefore, I now have the equation of the circle. I would think you probably only need to copy the right-hand side, Vic.
Yeah. Let's see if I can do that. Okay. Copy.
Copy that.
Let's see. Okay. Man, it just puts it so big here. Let's see where. Why won't it I can't move it in the right place. I don't know why I'm having trouble with this today. It's never given us this trouble.
Well,
Um,
shrink it smaller and see if you can just fit it on the side of it, because it's trying to lock it into a discrete position. It doesn't have the ability to do analog there.
yeah, look at my
It's locked above. There you go. It's locked above it.
yeah. Okay, let me,
There you go. Just put it on the side.
yeah, just put it on this side. Wonder if I can go over the boundary. Okay, I'll just leave it like that.
That looks good.
Now it's about, see, now I think I can move it onto it. Okay, I'll leave it like that.
That works.
Yeah, and I can fool with this later even. Okay, so that was the circle problem. Let's see. Next we have, okay. So this one, this objective is reading a graph. So we give you a graph and we ask you several things about the graph, and we can ask a number of things. These are not only the only things we can ask you even more than these questions here. But I think this pretty much covers it. Lots of questions here. All right, so look at the graph carefully. And we'll go through these. I'll put the answers in the blanks here. Okay. What is the domain of F? Does anybody want to volunteer? What's the domain of F?
All real numbers.
All real numbers. And it says type your answer in interval notation. So negative infinity to infinity. Infinities always have the parentheses, always open interval. The range of F. Anybody want to say the range of F?
It looks like -4. I can't really tell from here because I'm on the tablet.
I think it is -4. We can go down and look at the answer. Do we have the answer to this one? Yeah, -4 to infinity. So of course you will have a better view on your test. So it is -4 to infinity. It is. Okay. All right. What about the zeros? I think they're pretty easy to tell.
It
Anybody?
looks like one is at x equals 7 and one is at x
Mhm.
equals 3.
I believe so. So the left zero of the function is 3 and the right zero is 7. So they actually gave you the 3 as well. What's the y-intercept?
21.
Yeah, I think it's 21 as well. And they are just asking like just the numerical value of the intercepts, but we could write them as ordered pairs. You guys know that. All right, on what interval is F increasing? So we have to know the value of the vertex. It looks like it's 5. The X value is 5. So what do you guys think?
It would be increasing from 5 to infinity.
Absolutely. Over what interval is F decreasing?
0 to 5.
Yeah, 0 to 5. Over what interval is F constant?
Negative infinity to 0.
Good job. Negative infinity to 0. What is the number at which F has a relative minimum? So they're asking for the X value. When it says at which, or if it says where, sometimes they'll say when. Those describe the X value, okay? And then the part I, what is the relative minimum of F? That's the Y value. So where does F have a relative minimum? We already said it, right? X equal 5. And what is the relative minimum? Okay, well, I can't tell. Did we say, we said -4, right? Yeah, we said -4. What is F of -2? Well, I think it's that 21, right? 21. Oops. All right, let's see. What are the x values where f of x is -3? The leftmost x value is -3 when x is 4. What is the rightmost x value where f of x is -3? Okay, so it's saying it won't let me keep a zoom in, but it said 4 -3. I guess it would be 6, because 4 is 1 unit onto left of 5. Symmetrically, 1 unit on the right side of 5 would be 6. So I'm going to say x equals 6. And we can check it. Is f even, odd, or neither? What do you guys think? F even, odd, or neither? Even means symmetrical to the y-axis. Odd means symmetrical to the origin. Neither means neither of those. Anybody want to guess? Or
Either.
want to answer? Neither. Exactly. Okay. And let's just check. Yes, 6 was the other value where f of x is -3. Okay. Any questions? We could ask you something like, what interval is the function less than 0? And that would be between the x-intercepts. What were the x-intercepts? 3 and 7. So it'd be the interval 3 to 7, something like that. They could ask you where the function's negative or positive or something. Other than that, I think they pretty much asked you everything that you would kind of need to know. All right, any other questions? All right. So here's an exponential equation. We solved the logarithmic equation. Here's an exponential equation. So Dave, take this one.
All right. So we have 2e to the 7x. Oh, wait, it's not annotating. So I have 2e to the 7x is equal to 1262. Okay. So this is very similar to one of those setups when you're solving for something that has a compound interest and things like that. The little acronym that I always tell my students is the DLD, divide, log, divide. And you can vary that pattern, but you'll notice it's exactly what we have. I have a multiplication, I have the e base that I need to get rid of, and I have another multiplication up top. So I'm going to be doing a couple of divisions and a logarithm. Also, the key thing that waves a big red flag for, hey, you're going to need a logarithm, is the fact that my variable is in an exponent. So you know there's going to be a logarithm necessity in there somewhere, because that's a log's job. A logarithm finds exponents. It calculates an exponent. So I'll start by dividing by 2 on both sides. Then I'm going to have e to the 7x is equal to 631. From here, I'm going to put the logarithm on both sides. And in this case, the ln has the same base as the base e. So I am actually able to cancel. Don't always like to use that word, but I am actually able to wipe those out because they're the same base. So then from here, we're left with 7x is equal to the ln of 631. And I've got one step left. I'm going to divide by 7. So if you have to leave your answer in exact form, this is the way it should be. The ln of 631 all divided by 7. Do not make the mistake of letting the 631 divide by the 7. Order of operations puts logarithms up at the front with exponents. So I can't do the division since it was on the outside of the logarithm until after I've actually performed the logarithm. So then the approximation, I hit ln 631, close my parentheses, and then divide by 7. And I'm getting that this is approximately 0.92104, which they said round to 2 decimal places, so 0.92.
Okay. I'm going to snip that. I'm going to snip just the side like I did it last time.
Makes sense.
Okay, you can take it out.
Yikes.
I know. Okay.
Just really wants to be a meathead today.
I know. It's I don't know why exactly. I'm not really sure. What's the deal?
You know
Then I
what?
can
I
put
just thought of something, Dick. Whenever
what?
we were working on that OER project, do you remember how everybody in Tennessee and Arkansas and everybody all at once was able to edit that document simultaneously?
Yeah,
I mean, we should probably think of a Google Doc or something like
a
that
Google. Yeah, that'll be a good idea. That's actually a really good idea.
where we can
That way we can both. Can you draw in the Google Doc or you just type?
all we can do is try.
Okay. Okay. Alrighty. So in this particular example, I kind of combined a couple of problems together here. I've put some extra stuff you'll see, and I altered the functions just a little bit to give it a little bit more realism to what you would find.
You change
Yeah, I changed one of the functions to a quadratic just to give it a little bit more dimension.
so that no more good.
And then I asked some composition questions here. So let's look at these functions here. F of x is linear, 3x minus 5. G of x, I put quadratic, x squared minus 4. Okay, so f plus g of x. Okay, so let me kind of erase this. Y'all don't let me forget to do this compositions, but I just want to move these over a little bit. So f plus g of x, well, f plus g of x, as far as notation, it means this. It means f of x plus g of x. And f of x plus g of x is simply 3x minus 5 plus x squared minus 4. I'm going to put them in descending order and combine the negative 5 and the negative 4. Actually, I'm going to get minus 9, huh? So I'll get this. So x squared plus 3x minus 9. Any questions? Okay. And as far as the domain, well, it's still polynomial. So the domain of a polynomial function is just negative infinity to infinity. Now, f minus g of x, that's a little different. It means f of x minus g of x. And f of x is 3x minus 5. But when I go to subtract g of x, you're going to have to put that in parentheses because you got to subtract all of g of x. Don't just subtract the first term. Subtract all of g of x. So therefore, I get 3x minus 5 minus x squared plus 4. So I get negative x squared plus 3x minus 1. What is its domain? Same thing. It stayed polynomial. So negative infinity to infinity. Any questions? You guys stop me at any point when you have a question. All right. All right, f times g of x. Well, that means f of x times g of x. So that is what? 3x minus 5 times x squared minus 4. Now you got to double distribute. You got to distribute the 3x and then you got to distribute the negative 5 and then combine like terms. So 3x times x squared is 3x cubed. 3x times negative 4 is negative 12x. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 4 is positive 20. And I just like to put my terms in descending order. All right, what's the domain of this one? Same thing, right? It's still a polynomial, so negative infinity, infinity. Now the next one, the domain is going to be different. Okay, so let's look at the domain of this one. F divided by g of x. That's f of x divided by g of x. Okay, so what is that? Was it 3x minus 5 over x squared minus 4? And I'm just going to leave it like that. Now, I see that x squared minus 4 factors, but it doesn't factor into a 3x minus 5 to simplify. So I'm not going to factor it because it doesn't simplify. If it did simplify, you know, then I would definitely do that and you know, factor it and simplify. But I'm seeing ahead of time it doesn't. Now, anybody want to say? Did I do that? Is G? Oh, guess what? Guess what? I altered the problem. So the
Yeah,
multiple choice is not here. All right. So anybody want to say what is the domain?
it should be negative infinity to 2 union 2 to infinity.
Right. Negative infinity. Okay. So negative 2. You might have missed one, Austin.
Yeah.
Negative 2 to 2. I think is what you meant to say. 2 to infinity. Okay. So this right here is the domain. Yeah. Okay. So I altered the problem. That's why the choice is not there. Okay. All righty. Any questions? Okay, let's do the compositions. The compositions are just a little level higher. Let's see, how much room do I have on the bottom? Oh, I got a lot of room here on the bottom, so I'm going to do it down there. So let's do, this would be what, part E, let's say. F composed of G of X. Well, what that means is it means, when I say F composed of G, G is inside F. When something is composed, like a soup is composed, let's say chicken noodle soup, it's composed of chicken and noodles and maybe it's carrots or some little vegetables or something. So F composed of G means G is in F. So I'm going to take G and I'm going to put it in F. Now F was 3x minus 5, right? So I'm going to put the G function. Let's look at a visual up here.
So is G the noodles then?
G is the noodles. G would be the noodles. And I put it in F. So I take all of G, which is x squared minus 4, and I put it where the x is. X might be in multiple places, but here it's just one place. So 3 times, instead of x, I put G. Okay. All right, so let's go and figure that out. So what do I get here? 3x squared minus 12 minus 5. So 3x squared minus 17. And then let's do an F here. What was it? G composed of F of X. So that means I go the other way. I put F now into G. So if I put F into G, you can see there's still only one place where X is, but that's what I'm gonna do. So I'm gonna have to let's see, square the 3x minus 5 and then subtract the 4. So if you go off to the side and square that, so you might could do this in your head with a formula. So it's 9x squared minus 15x minus another 15x plus 25.
Where'd you get the -5 from?
I think it was 3x minus 5, right? The F right here.
Yeah.
Oh, okay. Oh no, I'm sorry, I didn't see that.
Yeah, and then I put that right into the X. So
X
then I
minus
got to square it minus 4.
But Miss Flanders, shouldn't G
Yes.
of F and F of G be the same?
If they were inverses, they would be the same, but not, so that's for two special functions that are inverses of each other. So not necessarily, no. Good question. So my final answer is 9x squared minus 30x plus 21. And there is something else. There's one more thing maybe I can go over. Suppose we have either one of these functions. Suppose we're asked to find like f minus g of 2 or f composed of g of -1. Suppose we have any of those. Let me do those off to the side. So EF, let's do maybe a part G, because sometimes you'll see a question.
Maybe you should do part K, so it's not confused with function G.
Oh, let's do that. Okay, I was going in alphabet, but you got a point. Let's do part K. Let's ask f minus g of 2. And there's two ways to do this, but I've already computed f minus g. All right, so I'm going to put in 2. So negative and only 2 squared plus 3 times 2 minus 1. So I have -4 plus 6 minus 1. So I just get a 1. And then I could also ask maybe g composed of f of -1. So I'll go to my g composed of f function. And I'll put 9 times -1 quantity squared minus 30 times -1 plus 21. So I get 9 plus 30 plus 21. So 39 plus 21, I think that's 60. Is that right? Guys, check me out. That's 60. Okay. So you might be asked to, to find, like a function and then find, a value of that, a function value using that new function that you created. Any questions? I think I pretty much covered everything that you could possibly be asked about this. David, any question? What?
I actually do have one.
Okay.
And it's in the theme of a special day.
Oh.
How does NASA plan a birthday party? How does NASA celebrate a birthday party?
I know. Is it my birthday party?
It might be.
Yeah, it might be.
How
does NASA celebrate a birthday party?
They plan it.
Planet. Okay, I'm playing words. Planet.
Right.
Got it.
How does a pickle celebrate his birthday?
Pickle. I don't know.
He relishes it.
Those are funny. I enjoy it. So I think what Miss Tony's getting at, today is my birthday.
Happy birthday.
I'm 35.
Happy birthday.
Oh,
Happy birthday.
31.
31. I miscounted. Math professor here miscounting 31. Exactly.
Happy birthday.
Thank you. Thank you guys. Look, I'm spending my birthday with you guys. Isn't that so nice? I do have to work for a little.
Teacher.
What's that?
Huh?
I didn't hear what you said.
I said I couldn't have asked for a better teacher.
Oh, well, thank you. I do have to work for a living, so it's professional. But anyhow, celebrate this evening. But anyhow, here's the next question. Dave, thank you for that. Little birthday jokes.
Oh, wow.
All right. So we want to list all the rational zeros possible, and then we want to use synthetic division to test. And then we want to use what we find to finish out the answer.
Yeah.
It's interesting to me that they answered letter B, because they answered it just one specific one. You see, but it could.
Yeah, I don't know, because
any.
it could have been any of those in part C, the 2, the 3, or the -3.
Right.
Yeah, I don't know.
Okay, so rational root theorem. Let me annotate.
And while I'm thinking about it, because I tend to forget very easily, I did say I was going to award bonus points for these final exam workshops, the one today and one tomorrow, but you have to come and participate. So make sure you put your name in the chat, and make sure you can answer a question here or there when I ask for, well, either Mr. Simon or I ask for volunteers for answers and stuff like that. Make sure you participate.
Dad jokes don't count. Disclaimer.
Well, you're participating. So
I don't get
anyhow,
bonus points. Remember, they took away all our extras.
they took all our bonus. We don't get bonus points.
Yeah.
But make sure you put your name in the chat so I have a record that you were here, and do try to participate. Do try to ask questions or answer questions that we ask. All right.
Okay,
Yes.
so I've got my polynomial, and you notice I set it equal to 0 because that is what we're actually solving, whether it's a function or just the equation itself. Eventually, it comes down to the same thing. I want to know where this polynomial would equal to 0. What x values would cause an equality to 0 for this polynomial? So typically, you'd want a factor, but most of these that you get are not factorable by the conventional methods that you've been shown before this. So the most generic method we have is to make a list of guesses and then to continually guess using synthetic division to break down the polynomial into chunks that become smaller and smaller every time you get one of the guesses correct. So the rational list comes from the factors of the constant end divided by the factors of the leading coefficient. So in this case, the factors of my constant end are 1, 2, 3, 6, 9, and 18. And then, of course, on the other end, just 1. So then the list is going to be every one of those on the end over 1, but then plus and minus. So I've got 1, 2, 3, 6, 9, and 18. And then, of course, all of the negatives, -1, -2, -3, -6, -9, and -18, all of which could possibly be something that would make this equal to 0. So, of course, one of the things that you could do at this moment would be to just plug the number into the equation above. Sure, you could do that. However, the method that we've developed with synthetic division allows you to get more of a twofer action going on, in which I mean, not only do you get to know right away if your guess is successful or not, but after you're done with the division, there's a chunk left over that's smaller than the original equation. So for example, let's say that I guess 3. I put 3 in my box for the synthetic division, and I put my coefficients 1, -2, -9, and 18. I put my 0, draw my line, and then proceed to perform my synthetic division by adding and multiplying. Adding, right? So I get 1, multiplying, adding, get -6, multiplying, I get -18, and then I get 0. And that's the success. When I get a 0 remainder from my division. Okay, but also don't forget that what's left over here is giving me this new equation, x squared plus x minus 6. So not only have I succeeded in saying, hey, look, x equals 3 is a solution, but also I made the equation smaller. So one thing you could do now is you could conventionally factor this, or you could continue to synthetically divide, meaning I could take something like the x equals 2, right? Put it in the box. And then I could take these coefficients right here, this, and divide it. It would be the 1, 1, -6, do my synthetic division, and notice I got a success again. So x equals 2 would also be one of my solutions. And then once you get to this point, you need to recognize that what you have is x plus 3 is also equal to 0. That one doesn't require any further divisions or factoring. You can simply get the last solution from there. So synthetic division is designed to not only tell you when you've guessed correctly, but it also, every time you do guess correctly, gives you something easier afterwards to solve. And in this case, I was able to synthetically divide all the way down. In synthetic division, and all the ones that we've studied and all the ones that are typically studied, since they are rational coefficients in polynomials, they don't allow irrationals or imaginary coefficients, then you will be able to synthetically divide at least to the quadratic level, if not to the linear level like I did here. So one way or the other, you can finish up either with the quadratic formula or with the solving like I did here. Did you get it, Vic? I saw it.
Yep, I got it. And I'm gonna like minimize it now before I put it in.
Yeah, there you go. It might work this time.
Try it. Okay, well maybe.
Yeah, you see, it did it, but you were already ready for it, so.
Yeah.
Nice.
So let me put it back. I think it goes up here.
Bring it out to the side first.
Yeah, I'm trying.
Somehow it likes that better.
Yeah. And then I can blow it up right here. I can make it a little bit bigger. Okay. All right, so this next one is transformations. And I have a little note here to study all 5 of your basic function graphs. So, and actually there's even more, and then your exponential and logarithmic, we did those with transformations as well. But anyway, the first time you were introduced to transformations, you had 5 basic graphs. You had a parabola, absolute value, which is here, a square root, a cube root, and a cube. So you had basically 5 different basic ones. So make sure that you study all of those, because this one is the absolute value. Okay, and make sure that you can give me what basic function it is. So in other words, if I just give you this h of x is absolute value of x minus 2 minus 3. If I ask you what is the basic function, you need to be able to give me, this f of x. So make sure that you can give me this f of x. Okay? And then make sure that you could answer what are the transformations. So right here it's asking me what are the transformations. Well, it looks like I have the x. I'm going to write them right here. I see that I have to shift 2 to the right. Okay, let me rearrange these. Shift 2, let me say shift right 2 units. And then what does the minus 3? Anybody want to say, what does the minus 3 make me do?
Shift to the
Anybody?
left.
No, a plus 2 in. Okay, so let's kind of go over the notes. If a number is added or subtracted inside the function, so inside the absolute value here, it makes it go left or right, opposite of that number. So a minus 2 actually shifts it to the right.
Remember, it's because our center always starts at 0. So if you want your center to still be where something is zeroed, take whatever's inside the object and ask yourself which x value would zero it out. So in this case, x minus 2 is zeroed when I do 2 minus 2. So it must have been shifted to positive 2.
Absolutely. That's exactly it. Thanks, Mr. Simon. Now the -3 is outside of the function. And you can think about adding 3 to both sides, and that would be with the y variable. And the y variable, think about the y-axis up and down. So that -3, okay, you can think about it on the other side as a +3. And if you zero out the y +3, okay, all right, you would get -3. That would mean you would go down 3. So we're going to shift down 3. Dave, do you have a good way to explain that one?
You talking about the vertical shift?
Yeah.
Since it's on the outside of the function, it directly affects the output. So the y's are directly affected in the way that you see. So in this case, they're all subtracted by 3 simultaneously, which shifts it down the y-axis. I also have my my GeoGebra demo that I've programmed with this.
Well, let's do, yeah, this is a good one to do that on. Let me go ahead and so let's see. We have a vertical translation and we have a horizontal translation. And let's pick the right graph. So shift to the right 2, down 3. So it's C or D. I'm having trouble. I guess it's D.
It's D.
Because I just have no trouble zooming, but just do exactly what it said. Yeah, D. I think part C is backwards. The 3 and the 2 are backwards. So I think it's part D. Let me not put a, I guess you should like close it in.
Wait, so is it C or is it D? Because the answer at the bottom says C, right?
No. Oh, I think it says D.
Oh, D. Okay, yeah.
For the graph, it does.
Yeah.
Okay. Let me make sure it's clear. Okay. All right. Take over, Dave, and do the GeoGebra.
Okay, can y'all see that?
Yeah.
Okay, so right now, the function. Let me go ahead and set it back to normal. And this is a quadratic. Let me change it to an absolute value. Wasn't that what it was? It was an absolute value?
Yeah, it was absolute value.
Okay.
And specifically, I don't know if you want specifically x -2,
Okay.
and then -3 outside the absolute value.
Right. So the way I have this thing set up right now is so that you can see what happens here. So if I want to go the left and right shift, you see my H value is set at 0. So what happens if I bring it to the left? You see, I actually the graph moves to the left when I
Yeah, I
move
see.
to the left.
The name of the graph is, yeah.
Look at the equation. The H value is actually -2, but it's x plus 2, like I was saying before. It's zeroed out the inside there because the center point should represent an output of 0 still. Okay, so you had -2 though, right? So it should
Yeah.
be the other way, like that.
Yeah.
Like that.
There it is. Yep.
And then you shifted it down 3.
Yeah.
So like that.
Yeah. That's it.
So notice the equation, and then again, notice the way that this thing has to be set up. It's shifted to the right 2 and it's down 3.
Yep.
Okay.
All right. Looks good. Okay.
Alex, you had a coffee shop?
I'm outside La Madeline's because I was running. Well, I went to get my vaccine shot and I couldn't make it home in time, so I just stopped and got coffee and attended class.
Oh, I'm not complaining. It's really nice scenery.
That's good.
The wind is really bad, so that's why my camera's been off half the time because all my stuff is flying everywhere.
Well, it's a pretty
It's
day
nice
outside.
It is. It's
Well, I
really
guess the
pretty
gnats
outside.
aren't too bad then, because the gnats are really bad over here.
They
Yeah.
are.
Nice day for a birthday.
It is.
Exactly.
Except I'm stuck inside. I'm not outside like Alex. All righty. So the next problem is, well, Dave, you just got through GeoGebra, but it's your turn.
Yeah, I'll do
So,
this one.
yeah.
Then I'll GeoGebra that one too.
Okay.
Fine, you twisted my arm. I'll GeoGebra.
And we'll see how many more we have so that we do all the ones at least I circled, I hope.
All right, hang on. I'm pulling up. Okay.
While you're doing that, I'm going to get me a
Here. What's that?
drink. I said, while you're doing that, I'm just going to go leave for a minute, go get a drink.
Hey, Vic. Maybe you should go get a drink.
Okay.
Okay, guys. So what we have here is a system of linear equations. Basically, what we're finding is where these two lines intersect. A lot of times they like to teach the method of this by saying, oh, well, let's graph them and just see where they intersect. But in actuality, in a lot of the situations that involve this, it's more about the other way around. Like, hey, I'd really like to graph these things accurately. Let me figure out where they intersect. So the other two methods that they employ besides graphing are the substitution and the elimination. And it really just comes down to which one has, less steps and can get through it quicker, or whichever one makes more sense to you. I personally have always liked elimination if I had to choose between those two, because substitution can have more steps and possibly involve fractions if you don't have something set up the right way. This one would work good either way, but I'm still going to do elimination. So I have 5x minus 2y is equal to 4. And I have 4x plus y is equal to 11. And what I would like to have is one of these variables go away. And I'm going to use the fact that I can actually add equations together as long as they're in the exact same format and they have all the like terms lined up. So in this case, my x's are lined up, my y's are lined up, my equal signs and my numbers are all lined up. And I'd really like one of those variables to go away. Let's say I want to get rid of x. So what I'm going to do is I'm going to start by multiplying each equation. The top one I'm going to multiply by 4, and the bottom one I'm going to multiply by 5. And that's going to give me 20x in both of them. But I want them to zero out. So instead, I'm also going to multiply by a negative 5. Actually, you know what? Since there's a negative in the top, let me do negative on the 4. It really doesn't matter. I noticed the double negative will work out better this way. Okay, so when I perform this multiplication, then I receive negative 20x plus 8y is equal to negative 16. And 20x plus 5y is equal to 55. Okay. So I now go ahead and add these together, which zeroes out my x's. I'm left with 13y is equal to 39. Of course, dividing both sides by 13 shows me that y is 3. Now, of course, another method from here would have been to go ahead and eliminate again. The fastest way is to go ahead and take this y equals 3 and substitute it into one of the equations. So that would be, for example, I could plug it into the bottom equation. 4x plus 3 equals 11, which of course, when I subtract 3 from both sides, gives me 4x is equal to 8. Dividing both sides by 4 gives me x equals 2. So I then have my pair, the 2 comma 3. Got it, Vic?
Sorry, I thought I was unmuted. Still, I thought I was unmuted. Yeah, I got it.
Okay. So here, if you notice, these are the two lines that were given in that problem. The 5x minus 2y equals 4 and the 4x plus y equals 11. And you can see that they do in fact meet at the point 2, 3. But we could also actually have the thing compute the intersection point just for clarity. And you can see it even calculates that. It's definitely at the point 2, 3.
Okay, so I think we just have one more problem that I've highlighted. So we might finish up a half an hour early here and just answer some questions if you guys want. So the last problem I have here is a difference quotient problem, giving you a function and asking you the difference quotient. So here the difference quotient is given. I'd like you to memorize this. You will see this again in calculus with another operation in front of it called a limit. And that will give rise to the whole meaning of calculus, or how calculus was derived. But anyhow, we have a f of x equals x squared minus 3x plus 7, and we're asked to find the difference quotient. Okay, this f of x plus h minus f of x all over h. Okay, so I'm going to do that off to the side here. I'm going to write out my formula. So f of x plus h, that means I take the binomial x plus h and I plug that into f, okay, into the function for x. So I replace x with the binomial x plus h. So that's going to give me x plus h quantity squared minus 3 times x plus h plus 7. Then I come to the minus sign in my formula. So minus, then I subtract f of x. Now f of x has 3 terms, so make sure you put that in parentheses because you're going to need to distribute the minus sign. And then all over h. Don't be lazy and forget to write that divided by h. Okay, so make sure that you're writing equivalent statements. Now if I square x plus h out, I will get x squared plus 2xh plus h squared. Okay, you're not going to get x squared plus h squared. It's a very elementary mistake. Don't make that mistake. Okay, so it's x plus h times x plus h. If you do that, you get x squared plus xh plus xh plus h squared, which is x squared plus 2xh plus h squared. Minus 3x minus 3h plus 7. Then distribute this minus sign. Minus x squared plus 3x minus 7. All over h. Then I'm noticing that some terms are canceling out or subtracting out. X squared minus x squared. Negative 3x plus 3x, 7 minus 7. And everything where you had the minus f of x, all of that, so subtract out something with the f of x plus h. Okay? And it does. So I end up with 2xh plus h squared minus 3h. And I'm noticing that each term in the numerator has an h. That needs to happen because I need to factor out that h. So I factor out that h. And then it divides out with the denominator's h. And what I'm left with is the answer. So my answer is 2x plus h minus 3. All right. And I think, let me go through this document. Yeah, that was like the last thing, huh? All right, let's see. Let's go through this and see if there's any other answers, problems that I had circled. Just want to definitely work the ones that I chose to work. And you guys can ask for other stuff. I'm just going to go make sure I have everything done that I have circled. So I'm just going through here, scrolling through here. All right. Okay, do we have any questions? I can go back to the study guide. Anybody have a question about any other problems on the study guide, or about the problem we worked on the study guide, or any other questions that you have for us?
All ears.
A couple things.
Okay,
Can
Parker?
we expect to see like a PDF of this whole
Yeah.
thing that like, worked out or not?
Yeah.
Just
So-
us?
Yes, sir. So just like all the other workshops for the exams, I post the recording of this video with the document, and the document is written on. So like you'll see our work. You notice that I'm copying Mr. Simon's work and putting it in the document, and you will have that as a PDF, and I will post that. I'll put it in an announcement. I'll say, here is the video recording, you know, and here is the document we use in the workshop. So it's going to be in an announcement. I send it in an email, and I put it as an announcement on Canvas.
Sweet.
So yes.
Actually, just like one more question is like a
Sure.
final note actually for Mr. Simon. I've noticed like in each like of the workshops, whenever you solve a problem, you usually like 90% of the time you graph it. Like somehow how I don't understand, you put it on a graph. Like there's no way you could graph this problem, and it graphs it. I'm just wondering like how like is it just to be thorough, or is there like more behind it?
I guess you mean with GeoGebra. Yeah, he's a master of that. Go ahead, Dave.
Well, I don't know. Do you mean GeoGebra, or do you mean I write the graph?
I mean, like you like a problem that we work in the exam workshops. Like you take it and then you just put it on a graph. Other times that I've worked that problem, like homework or something, it doesn't mention anything about graphing. I mean, I'm just wondering like why you put it on a graph, because obviously you can put like, you know, you can find any equation pretty much and find some way to graph it. I'm just wondering why.
Well, not every equation has a graph, but all of the ones that have two variables for sure. But a lot of times this algebra course is a beginning of what we call analytic geometry. And there's actually going to be, or there should be, two sides to all of these things. And unfortunately, we're not able to have enough time to show you absolutely everything. But when I teach, I try to get the visual side of everything in there, because it's what's really going on. And the algebra is more like the background. You know, this is the stuff you need to do, but then this is what it looks like, you know. And knowing all of the graphs and shapes and how they move and things like that, and the ability to draw it down there, just gives you that other side of your brain to link together and help you remember it, understand it better. Because I'm actually horrible at memorization. I can never remember things very well at all. I have to re-visualize formulas, even the simplest ones, every time I use them, because I can't memorize letters and symbols like in just large gobs like that. So having the visual side, in my opinion, is a good supplement to helping you remember and learn it.
Okay, so it's like training that visualization, right? Like we just putting it there because that's where it ultimately goes.
Right.
Yes. And
Okay,
it makes
all right.
sure it helps you understand things much deeper. And
Like
graphing is a big part of calculus, especially the beginning when you're doing limits. Having a lot of these graphs, understanding them is going to be so much better for you as far as whenever you go to learn calculus. So it's a really, and the reason it's not in your homework so much is because your homework is a technology tool. And a lot of times the graphs are just like multiple choice or something like that. You saw the transformations, you know, I'm this study guide's from my math lab. So it's not, and you know, when you did graphs of the sine and cosine functions and all the transformations, you know, you had to turn that homework in on paper. And the same thing with polar graphs, you turn that homework in on paper. And the reason is because graphing is so important. And on the computer, when you do it in my math lab or whatever, it's not as you don't learn it as well as I'd like you to learn it. So graphing, is very, very important in terms of algebra and trigonometry.
It's actually pretty interesting. Huh. Nice. All right. Well, thank you. That's pretty much
You're
all the
welcome.
questions I had.
Yeah, no problem.
Wow.
Anybody else?
I do have questions about test
Okay,
taking
Daryl.
strategies. It's in regards to the math test. Whenever we have like lots of calculations in between problems and stuff, you know how if you make one small mistake, you can like screw everything up. How do you guys go about calculating in tests?
Well, you've had me for a whole semester, so you should know how I do that. So I try not to put so much emphasis on taking points off for wrong calculations, like just a minor,
One thing that messes
calculation
up.
mistake.
Yeah.
I try to put more points on the concepts conceptually. Are you doing this conceptually? And not so much on the little calculations. And you'll see in calculus, that's going to be really important to understand the concepts. But we are going to have a lot of algebra to do. Like a lot of times, I'm going to give you a function. I'm going to say find this function's derivative. Okay, and you're going to do one step calculus and then about 5 or 6 steps of algebra. So it's going to be really important that you learn how to simplify algebraically. So calculus class is not just about learning calculus. It's about learning calculus, but understanding in great detail algebra and how to simplify and how to solve.
Honing your algebra.
Yes. So sometimes you guys think that some things are simple calculations, but like factoring and things like that, that's not exactly a simple calculation. I'm talking about like when you miss 2 plus 3 and you put 4 instead of 5. Well, I know 2 plus 3 is 5, but whenever you miss things like sometimes simplifying incorrectly or different kinds of things, you don't know how to get a common denominator or you can't solve an equation, those are not just little calculations. Those are conceptual things that are very important, that you get correct. So sometimes I'll take off a lot of points on some algebra stuff that you should really know how to do, that I don't think is just a slip of the mind, or 7 times 6 is 42, but you put 40, or I don't know, something like that. It's not just that. So make sure you understand all of your algebraic skills. Review that before you take calculus class. Okay.
Because in like all of my tests, I know that I know how to do so many things, but most of my errors come from miscalculation. So
okay.
I think
So
practice.
what that should tell you is know your weaknesses, okay, and make sure you check over your work. Okay. And when you check your work, don't read it. Because sometimes students are just reading their work. If you just read it, you're going to read through the mistake. You actually have to compute over again. You have to train yourself to do it, because I used to be really bad at it. Sometimes whenever I see a student has a wrong answer, then I have to go through that student's work, and I can't just read through the work because sometimes I won't catch the mistake. I have to train yourself to actually compute every step, and it's a pain when I have to do that through students' work. It's a pain, especially when it's a long problem and I got to figure out, what did they do wrong. So so train yourself to rework your problem. So either rework it by hand, or if you do it in your head, you got to just make sure you're computing it, not just reading it.
Also, Ms. Sanders, also with Daryl, like when I was in school, like I'll make a fake test and do it before the real test. Like I'll actually do it, go out each one like it's a real test. So when I get to the actual test, it'll be second nature. I could just do it. Give yourself like a self test.
Yeah.
And you can see where you make your errors here and there.
Great idea. Great idea. That's being very proactive in your studying. A lot of times students say they studied for hours, but what they did is they just read through their notes. You can't just read mathematics. If you read through stuff, that doesn't tell me you know how to do it. You actually have to like Joshua said, make a sample test and work your problems and then grade it.
Also,
You know,
make sure you know how to use your calculator to perfection, because they got some people I've tutored. They in higher level. They don't know how to use the exponent on the calculator. I'm
I
just
know.
giving examples. So you study your calculator, how to use that log, ln, and all that stuff. Make sure I do it quicker. You know, when you change how to change a fraction to a decimal to a fraction on your calculator, stuff like that. Things that make it go quicker. You know, and also find your own way. Don't try to use somebody else's way. Find a way that's best for you. What is best for Daryl? Not what's best for someone else.
Right. What makes sense to you, to yourself?
And I see that Mr. Hampton put his contact information in the chat. He is one of the Center USA tutors, and very good. So there's his phone number and there's his email. So guys, if you need some extra tutoring, give him a call, give him an email, and I'm sure he'll be glad to help you.
And
Good to see you, Josh.
Good to see you too, bro.
All right.
Yeah, that's it.
Those are good questions. Good. You know.
Thank you.
Yeah.
So be the calculator, basically.
Absolutely. Let the calculator help you. It's and parentheses are a big deal about using when to use parentheses, because a lot of times students leave parentheses off when they're very necessary and then they get wrong answers. So it's a matter of understanding also how your calculator computes things. It just does what you tell it. Whenever you punch things in, it just does exactly what you tell it to do. So you have to know what to tell. You have to know how to use all those symbols and what those symbols mean.
Yeah, and the TI-30 calculator is a little bit different. Like the negative signs, you got the small negative is the white button on the right hand side. Then you got the big blue button, which is the bigger negatives. So it's a little bit different. So just play with it and get it.
I wish that you just had the one negative, just the subtraction sign.
That's the other calculator has it, but they don't have it. But
yeah,
that's how you just work it. Play with your calculator. That's what I had to do.
Yeah. So it's a matter of knowing your calculator. Exactly.
Yeah. If it's something simple, use that calculator, because when you take a test, it's one and done. It's like a playoff in NFL, one and done. You can have a 15-1 season. You mess up one time, it's over.
Yeah.
You could be perfect. Like the Patriots. I don't remember the Patriots had a 16-0 season, messed it up in the Super Bowl. That's how it goes. So don't be. Sometimes you gotta put your pride on the back window, on the back seat, and just use your calculator to your advantage.
Good point. All right. Anybody else? Before I'm going to interrupt just to say that tomorrow Mr. Simon and I are doing a trig workshop at 9 in the morning. So pre-calc for you guys, that's during your class time. So don't click on the class link because no one will be there. Click on the link you click today for these workshops, and that's where we'll hold class, and we'll have the trig workshop, and that'll be the second half of your final exam. So your final exam, first half is college algebra, the first 10 problems, and then the next 10 problems are going to be trigonometry. So you have 20 problems total.
We also have a couple of calculus workshops if you want to just come and hang out.
That's true. We have one this afternoon at Calc 2 and one tomorrow afternoon at Calc 1.
Where are the links for those?
Yeah, you can come see what it's all about.
Yeah, I'd like to, but where could I find the links for them?
Okay, so I didn't put a link in your class, but Daryl, are you part of the Center USA?
I am in that class on Canvas. Yeah.
Yeah. So are you getting the emails? You should be getting some emails, and they have a schedule. And they don't just have math workshops. They have like English workshops. They got all kinds of chemistry and physical science. They got all kinds of classes with these workshops. So they're very beneficial. Then there's some general workshops on just study skills and how to be a better student. Just very informative things that are out there for you guys to help you succeed. So let me know if you check that and you don't see a schedule. I can send you a schedule.
All right.
Let me know. But you should be able to click in the course, in that Center USA course, and see a schedule.
All right.
Okay.
So Vicki, if you send that today, is that a birthday schedule?
I guess it would be. I should have a big crown on, huh? It's my birthday, a big button.
No, no.
It's your birthday day, Miss Vicky?
Money.
It is. It is
Well,
my birthday today.
Well, happy birthday to you.
Yeah.
Happy-
Mr. Simon
do
said
you want us to,
31.
Miss Flanders, did you want us to sing us a happy birthday song like they do in
no,
Carousel?
no.
Happy birthday to you. Happy birthday to you. You don't want that? Huh?
Thank you, Josh.
It rhymes.
There you go. You don't want to do that? Or you want the Stevie Wonder version? Happy birthday to you. Like that? Well, congrats.
Gary, actually, thank you so much. Thank you very much.
Congratulations, though. Hope you have a wonderful one.
I did. I already had lunch with my daughter. She came, and we had a birthday thing over the weekend. So a big crawfish boil, and all the kids were here, and everything was nice.
And my birthday next month. On the
Oh,
30th.
okay. Oh, in May. Okay.
Almost close, 2 days apart, still a couple of years apart, but close enough.
Yeah. Yeah. Nice.
Hey, Vicky.
All righty.
I have a question for you.
Sure.
What did the gingerbread man do when he had a sore knee, when he broke his knee?
What did the gingerbread man do when he had a sore knee? I don't know.
When he broke his knee, he iced it.
He iced it.
Yes.
Nice. Nice.
I heard one. They had one on TV, a real Pharaoh, and they had a Mark Wahlberg. He said, "What is a car that eggs love?"
That what loves?
Eggs.
Eggs.
What car does eggs love?
I don't know.
A Volkswagen.
Dave, you can probably steal that one. That was funny.
That's a good one.
Volkswagen.
What do you call a guy with no arms and no legs on the front of your porch?
Oh, I know those.
Matt.
There's a bunch of those. Yeah, Matt.
Well, okay, what do you call the same guy with no arms and no legs in a barbershop? Harry.
I don't know that. Harry. Oh goodness. All righty. Well, I think we're still recording. By the way, all these jokes are on air.
Oh, I know. Well, if you want to do the same kind of jokes but cross over to animals, what do you call a cow with no arms and legs?
Oh, I know. Ground beef.
Ground beef. Yeah. What do you call those 2 legs? Lean beef.
Man.
I don't know. Chris knows that one. So my husband does dad jokes. He sends them to Emily every day, my daughter. So she has a dad joke in her class, secondhand, from him. So I get all these dad. I'm bombarded. I got Dave with these dad jokes, my husband with these dad jokes. It's like, oh my gosh, I'm bombarded with all these dad jokes.
Does he ever recycle mine?
Yeah, actually, yes. So I can't always remember them, but when I can, I do. The lean beef, I'll have to tell him. He might have said that one before. I can't remember.
And let's see. Why did the one I told last time? Did you tell about the why did the coffee file a police report?
I've already forgot it.
Because it was mugged.
That's right. How do I forget that? You just said that yesterday or something.
Oh, but one of my favorites is I've been having trouble with my dog chasing people on bike all the time. It's gotten so bad I've had to take his bike away.
That way you might have to process a little bit.
Yeah.
It's just the way you're saying your sentence. Yeah.
Right. Well, and commas, Vicky, commas.
Yeah.
They save lives.
Yeah. I know that.
You know that
Let's
one?
go eat grandma.
Yeah, I was good. The one I have is let's eat kids.
Yeah.
Or let's eat kids.
Yeah. I know.
That's a good one.
Yeah. All right. That's where those English teachers are take off points for.
Yeah, that's a good
wrong use
dad
of
joke for the English workshops. But anyway,
Yeah.
so
Exactly.
I'm gonna hit stop on my recording.
Yeah.